So in this video we're going to be proving trig identities. Trigonometric identities. So based on what we've learned so far in trigonometry, we're going to apply all of that, and proofs are one of my favorite things to do because I used to struggle with it so much. So let's start with sine 2x over 1 plus cos 2x is equal to tan x. So basically I want you to prove that this equals that. So let's get started. I'm just gonna put tan x here, and I'm gonna work with this side here and basically manipulate and simplify and expand and do whatever I want to this with facts, just to prove that it is equal to tan x. So one of the first things I'm going to do, I see sine 2x, that is a double angle formula, so I can rewrite that as 2 sine x cos x. And then I also have in the denominator, I had nothing to do with the 1, but I have a double angle here. So what I'm going to do with this, I have one of 3 choices, because there's 3 double angles formulas for, or identities for cos 2x, but I'm going to use this one, cos 2x minus 1, because I'm going to get rid of that 1, and then I'm left with, so these ones will cancel, I'll be just left with 2 sine x cos x divided by 2 cos squared x. And cos squared x is the same as writing cos x times cos x. So as you can see, the 2's cancel. One of the cos x cancels, and I'm left with sine x over cos x, which is the same as writing tan x, which is also equal to what I was trying to prove. So left side is equal to right side. So much fun. Let's do another one. Let's see. Let's do let's say we have sine x plus sine 2x is equal to sine 3x. I want to prove that this, that is not an identity. I want to prove that, so what I'm going to do is say let x equals pi over 2. So if I sub in this pi over 2 into here, sine pi over 2 plus sine 2 pi over 2, that is going to be a 1, that is going to be a 0, so 1 plus 0 is equal to 1. So my left side is equal to 1. However, my right side, sine pi over 2 times 3, that is equal to negative 1. So my right side is equal to negative 1. So left side does not equal right side, therefore it is not an identity. a simple number and check. Now let's go back to proving. Let's say we have cos pi over 2 plus x is equal to negative sine x. So let's work with this side here. We know that this right here is a compound angle. So remember our cos A plus B formula. So we're going to expand that here. And so basically we're going to have cos pi over 2 cos x minus sine pi over 2 sine x. So we know that cos at pi over 2 is 0. And we know that at sine of pi over 2 is equal to 1. So this is going to be 0. So this whole thing can cancel out. And I'm left with this 1 here. This becomes a 1 because that's what the identity is, and I'm left with negative sine x, which is also equal to the right side. And that, honestly, these are moving a lot faster than I expected. I was not expecting to get this quickly into it. Okay, let's try one more, a little bit more bigger. Let's try cos x minus y and cos x plus y. Let's try to prove this is equal to 1 plus tan x tan y divided by 1 minus tan x tan y. So let's look at the right side alone. So let's try expanding this. I'm going to look at just this side. So I have 1 plus, and if we look at the tan x, we can rewrite tan x as, sine x over cos x. And then we can write this tan y as sine y over sine cos y. And then in the denominator we can do the exact same thing. 1 minus that sine x cos x sine y cos y. And then what I want to do is multiply everything so that we can have a common denominator. I want to add the 1 to this and the 1 to that. So I'm going to multiply the numerator by cos x cos y over cos x over cos y. And then once I'm able to put all these under the same denominators, then I'm able to do this because I'm multiplying both of them. So if the numerator gets multiplied by cos x times cos y, this denominator here goes away, and that becomes cos x cos y. So cos x cos y plus sine x sine y. That's the numerator. Now for the denominator, same thing. I multiply this cos x and cos y into this 1. I'm left with cos x, cos y, minus, and this denominator goes away, and I'm left with sine x, sine y. And now you can immediately identify that this numerator is a compound angle formula for cos. You know, that is cos x minus y formula. And look, the denominator as well is the compound formula of x plus y. And guess what? That is our identity that we were trying to prove from the very start. This is why I like trigonometry and math. Everything is either it is or it isn't, and we can prove it. There is no opinions in math. It just is or isn't. Let's do one last one. Tan 2x minus 2 tan 2x. That's kind of long, so I'll write it over here. That's right. Sine 2x is equal to tan 2x minus 2 tan 2x sine squared x. So I'm going to try to take this and manipulate it into becoming that. So what I'm going to do is, first of all, I'm going to factor that out. Tan 2x, that'll give me a 1 minus. So I took a tan 2x out, so I should have 2 sine squared x. And I know what that is. That's one of my cos double angle identities. So that is tan 2x. I'll just write that here. Cos 2x. And let's rewrite this as because we have tan is tan 2x is the same as writing sine 2x divided by cos 2x, and we still have this cos 2x here, so this will cancel with that, leaving me with sine 2x, and that is my identity, proven to and through. So that is us proving some identities with everything that we've learned. Thus far. And I'll leave you with something, to practice. If you want. Something. Well, here. You can do. Well, I want to know how you could type this out into the comment section. Well, you can try it. Cos I shall see